Last time we have talked about the cached factorizer. This time let's write a test bench. Here is a test bench. Instead of get distracted by the javax.servlet, we want to study the synchronization. So we didn't create a servlet container. We didn't set up a JBoss Jetty Tomcat and use a browser to do the HTTP request. Instead, we just write our own servlet interface. We didn't use a javax.servlet interface so that we can change the service signature. Here, we use toString builder instead of the servlet request and a servlet response. String builder is fine here. We didn't use a string buffer, which is a thread-safe version. String builder is okay because at any time, only one thread is serving a HTTP request. So string builder never shared between two threads. We are okay here. The cached factorizer need to implement the service method. String builder is used instead of a servlet request and servlet response. Let's copy the code block from the example. Exactly the same. We also implemented those spaceholder functions. For the encoder into response, we get the first element of factors appended to the response. For the extract from request, we create a big integer from the request. The factor is the same as the example. Next, the cached factorizer test is trying to simulate a servlet container. In the main function, we run the run multithread function. Here in the for loop, we start a thread pool for 40 threads. It's not a thread pool, but let's pretend it's a thread pool. We allocate 200 threads to serve our HTTP requests. Each thread only serves one HTTP request. Here is a run function. This statement simulates a browser's HTTP request, and we get the content from the HTTP request, which is simulated by a random number. We append the random number into the request. Then we call the service method in order to generate the response content. After that, we do the sanity check. We expect the request and the response is always the same. If they are not, we know we run into the multithreading race condition. Let's check out the service method. All the threads share the same code base. They use the same service code path to serve a HTTP request. The service method is defined in the cached factorizer, which implements servlet. Cached factorizer have some shared local variables. They are lost number, lost factors, hits, cached hits. So all the threads trying to update those shared variables, and they will step on each other if we don't use the synchronized statements to guard the shared variables. Since those shared variables are guarded, we should be safe here. Next, let's take some time to talk about the test bench itself. here we have a latch. The latch is used to make sure we start to calculate the total runtime after the last thread finish executing. The latch is counted down at the end of the run method and wait at the end of the for loop. That's a run multithread method. This for loop is used because we want to take the average time per run instead of just run multithread one time and use it for the time per run. And we throw away the first 20 rounds because during the early rounds, the JVM is trying to do the code optimization and it's not stable yet. Also, the cached vectorizer is used as an intrinsic log for the service. This is a reference to the intrinsic log. This also reference to the intrinsic log. Those synchronized methods are guarded by the same object, which is this. Okay, enough of talk. Let's run the program. It's take about 12 milliseconds. Again, 30 milliseconds. Let's see what happens if we don't synchronize the accessing to those shared variables. We strike out those synchronized keywords and run the program again. This time we are fine. Fine again. If we are patient enough, sooner or later we will run into the multithreading issue. Okay, this is the case. We run into the multithreading issue. As we discussed before, what could happen is, after running this if statement, another thread gets a chance to update both lost number and lost factors. Then the CPU cycle is returned to the previous thread. That thread is go ahead and fetch the lost factors, and the factors is the latest one. However, the I is still equal to the previous lost number, so we get a mismatch and the answer is wrong. That's what happened at the output. Next, let's see what happened if we didn't synchronize the updating of lost number and lost factors. We are fine this time. But it's just a matter of time we run into trouble if we don't use the synchronization correctly. Okay, this time we run into the multithreading issue. What happened is, as we discussed before, after running this statement, another thread gets a chance to run. So it finds the lost number equal to the current number. It go ahead to fetch the lost factors. However, the lost factors haven't get updated yet. So what returned is the lost factors from previous value. And you get the latest I, lost factors, and the answer is wrong. This example demonstrates in order to have the multiple threads serve the HTTP request in the service method, we have to use a synchronized keyword to guard the shared private variables.